Alrighty. Okay, so I have a simple scene set up, and what I'm going to run through first is I'm just going to run through the basic UI of Renderman to begin with. So here we go. So once you've installed and plugged in Renderman via the plugin manager, we're given two different ways of accessing Renderman functionality. We have the very top menu up here, which basically gains access to pretty much every bit of functionality we need for Renderman. And we also have a shelf along the top here, which hopefully is loaded at the same time, that you can access a lot of the kind of the core functionality that you need when you're actually working away with it. So what I'll do is I'll just work through some of these options up here. I'm not going to go through every single possible facet of Renderman just because there's so much to cover and I just do not have the time to cover it. But I will explain a bunch of things in here and a good portion of what's actually on the shelf as well. Now I do apologize if I sneeze or cough in the middle of this recording, but I'm still recovering from being sick, so I'll make no excuses, and I'll see if I'll mute my microphone as best I can. Alrighty. So starting at the top here, having a look at the Renderman drop-down menu, we have our first three options over here. We have render, which is essentially a still frame render. We have IPR render, which is basically like an iterative render that will continuously update when you move your camera around and when you make changes inside of your scene. And of course we have batch render, which is for batch rendering out a sequence of images. Cool. Now these are actually available over here on the left hand side as well. Not the far left one, but the three slates in. So we've got this one here, which is our single frame render. We've got the next one across, which is IPR, and then we've got batch render as well. Now when we do render, a little pause icon will pop up as well, so we can pause our render, and there's also a stop or cancel render button just there. Cool. Alrighty, so I guess actually I might just kind of segue in a little bit here just to kind of do an initial kind of setup for some of the options that you guys might want to do at the start before you start working with Renderman, because it'll frustrate you to no end if you're not sure what the heck's going on. First one I'll do is we'll just kind of jump into the render settings over here, and we'll actually just specify or basically tell Renderman how many cores we want to use, because essentially we might want to just do test renders and still use our computer, whereas if we just leave it as default, it's basically going to grind our computer to a halt and you send all available resources to the actual render we're doing. So let's go up to our render options first over here. Alright, so up the top here, I believe yours by default would probably say something like -1, I think, or 0. Essentially what that's telling Renderman is every time you hit render is to use all available cores, which means that you basically won't be able to use your computer for anything while it's rendering. So the ideal thing I like to do, particularly in the look dev or setup kind of phase of lighting and rendering, is I like to just basically allocate only half of my computer cores or resources to the renderer, because I'm not doing a final render, so I don't need it to be flash. And I know I've got 8 cores, so I can go ahead and specify 4. So that's just basically going to chew up half of my resources. Now I'm not going to really kind of cover everything we've got going on down here. Probably, I guess, a few things you want to make sure that you've got turned on is just down here, preview style, is that you've got it selected. I believe it's already set to it by default. And yeah, we'll just leave the rest of it as is, but that's just going to free up your computer while you're just kind of in the early stages of setup. Cool. Now I'm going to come down and have a look at the IPR renderer options as well, which is a little box on the right hand side. And the exact same thing here. Now I don't really care about quality with my IPR render, so the IPR renderer is generally just for kind of like the very quick initial setup, making sure stuff's kind of looking right. It's not there to really give you any quality. It's there as like kind of just a quick response to changes inside of your scene. So yours is probably set to 0 perhaps, I think, or -1, I can't quite remember off the top of my head. But I'm going to set that just to 2 because I'm not really too phased about it. It's just there as a quick reference tool when I'm setting up my scene. Down here we have camera. This is probably another really important one, is the IPR camera will come up, or the IPR renderer will actually jump over here and it will have a look at what you've got selected. Currently it's set to use current pane, so that means every time I hit render it's going to use whatever camera I'm looking through at the time. But if there's a camera that you specifically want to use, you can go down here and select it. So I can select my perspective camera if I just want to use my perspective camera, or I've got a render camera already set up, so I can go ahead and use that if I want. But for now I'm just going to leave it at use current panel. Cool. Now I'm not going to really worry too much about this. Probably the only other one that's really worth mentioning is down here under the update section. We have update mode, we have continuous, and we have on idle. Continuous means it's just going to continuously update, whereas on idle is only going to start updating when you stop moving your camera. So I mean, you guys can experiment it with your own time. Feel free to figure out which one works for you. I generally leave mine on continuous unless I'm actually I generally leave it on continuous, to be honest with you. Alright, so I'm going to close that all down. Cool. Now there's another thing that we want to make sure that we are using is down here under the renderer option is we actually have 2 different types of renderers. Well, they're essentially they're very, very similar renderers. Raise is the older kind of framework that Pixar have been using for some time, whereas the RIS, which is the latest and greatest, one that you definitely want to pick. We're not going to be taking a look at RIs in this workshop. Now I'd just like to point out that both of them come with their own selection of shaders. So if you choose to use RIs, you need to make sure you're using the RIs or the raise shaders, and the RIS you need to make sure you're using the RIS shaders. So make sure that we have our renderer set to Renderman RIS. Cool. Okay. Now there's another little bit of a setup that we need to make sure that we do when using Renderman, and that is how Renderman or how Maya evaluates our camera. Basically what happens is if we don't change this setting, you guys are going to get to the point where your renders stop updating. You'll be moving your camera around, you'll be changing your camera angle, your camera view, and the renderer will still be rendering the same angle or the same view. So we do need to come up to Windows up here, and we want to come down to Settings and Preferences, and we want to come over to Preferences, and we want to come down to Animation under the Settings tabs in the Preference window, and under Evaluation mode up here we definitely want to make sure, I believe you guys is currently by default set to Parallel. You want to make sure that it is set to DG, and that just means that, and hit Save, and that just means that the evaluation mode for our camera is going to work properly, and it's going to update the camera every time. Very, very important, otherwise you're going to run into a lot of frustration a little bit later when your camera does not update. Okay. Cool. Now we can't change the renderer over here. There is no other option to do it. You'd have to come over to here and make sure it's changed there. Okay. Below that we have Renderman Globals and Advanced Renderman Controls. They're almost exactly the same thing. If I click on Renderman, it basically just goes ahead and opens up our render settings. So if you guys are familiar with default Maya render settings, it's just like clicking on this little button over here and opening up the render settings menu. And it gives us access to all of the kind of the core features for setting up the quality and output values. Cool. And just below that one we have our Advanced Renderman Controls, which is exactly the same except slightly different. We have this new little kind of view over here. In fact, I'll open up both of them side by side. Cool. So you can see they're almost exactly the same. We do have a few extra option menus up here, which I'm not really going to go into for this lesson. And we do have this window over here for outputting different kind of, well, different outputs and different AOVs. whereas we don't have access to that in our actual render settings over here. Cool, okay, so that is the Renderman globals, and you can access the Renderman globals as well on the left hand side, just over here, the little slate with the little kind of sphere and plus icon next to it. Cool. Okay. Now I'm not going to worry about diagnose over here, and there's a bunch of options over here we're going to skip as well. So I'm just going to move down into this section here, mainly the top 3 options. So the very top one we have RMS materials. Now I just want to point out over here is they all have the prefix of Pixar, and that's the shaders that we want to use for the RIS shader. So make sure that any shader that you're using has a prefix of PXR. So you can access and apply your shaders this way if you want. Alternatively, you can apply shaders the exact same way that you used to with Renderman. You can right click and assign a new material, and you can see inside of the hypershade as well we have 2 different options. We have raise and we have RIS, and inside of RIS we have all of our Pixar materials because they are specifically for that renderer. So below that we have lights. Now we have 4 different lights. We have the Pixar standard area light, we have the standard environment map light, Pixar environment daylight, and the RMS mesh light. Now Renderman still comes with all of the lights that you're used to, so it will come with a spotlight, a distant light, area light, etc. They are all basically accessed via this light here. There's a little drop down menu inside of it that we can actually switch between the different lights, and we'll definitely be covering that later. Pixar standard light is a standard environment map, is basically an IBL, image-based light, where you can go ahead and you can plug in your HDRI IBLs that way and give yourself a nice lighting setup. And below that we have the Pixar standard environment daylight, which for those of you guys who are familiar with Mental Ray is almost to a certain degree or very very similar to physical sun and sky. And below that we have RMS mesh light, and essentially that is turning mesh into light, basically assigning a shader which makes it mimic light, and it's the most recommended way of emitting light from, say, mesh, as opposed to doing it through shaders. And we'll definitely have a look at all of these lights at some point soon. RMS presets. Now, these presets are pretty much for all of the different shaders that we have. Now, we can access all of the presets. Now, just kind of having a look at the presets here, you can see we've got a whole bunch of nice ones. Now, they can all be accessed the exact same way that you're used to if you're familiar with Mental Ray. You can go up to the presets tab up on the right hand side with your shader node selected, and select your preset that way. That way still works perfectly fine. In fact, that's still the way that I actually do it. Cool. I'm not going to worry about rib archive. I will kind of talk a little bit about ribs. I can't quite remember what the abbreviation stands for. I think it's Renderman index binaries, I think. But basically, it's a file that Renderman writes out every time you hit render, which contains render information, shader information, render settings. Basically, you can access everything inside your scene to a certain degree inside of the rib archives, and you can even use that to fire off your render again without actually having to go into Maya and fire it off that way. But it's a very very important node to get to know in the future if Renderman is something that interests you. And yeah, ribs are very very powerful, and it allows us to kind of take things to the next level. Create is a menu that allows us to just basically attach a few different attributes to shader nodes and polygon group nodes, and yeah, allows us to attach attributes essentially. And we can use the create menu here, or we can just use the attribute option in the attribute editor and just come down to Renderman like so and apply them as we need. And there are going to be a few attributes that we're going to have to apply inside of our scene. Alright, cool. Now below that, I'm not going to go over everything here. I just kind of want to point out maybe 3 of them so far, I guess. We got it, which will open up very, very soon. It is an external renderer that comes with Renderman. It's Renderman's renderer, and yes, it is called it. And it replaces the default Maya render view. However, you are still more than welcome to use the default Maya render view if you want. Both of them have their pros and cons, but it, I think, is definitely far superior to the default Maya render view. So that'll open up automatically when we render anyway. Now below that we have TX Make. TX Make is just a little conversion tool that comes with Renderman, and it's designed to convert all of our textures over to TX files, which is basically what Renderman likes or prefers when it comes to piping file textures like your diffuse maps and stuff through. You can still get away with not doing it if you want to, but Renderman automatically goes through the conversion process anyway, I believe, every time you hit render. So if you didn't want to do that process every time you hit render, you could run that straight away and just reference those text files instead. Cool. Below that is local queue. Local queue is just basically kind of like a little render information window that we can, if we're doing a bunch of batch renders with a few kind of with multiple different jobs on, it just basically shows the queue, shows the progression, and it gives us access to basically the error logs. Essentially very similar to selecting our script editor down here. Cool. And of course down here about Renderman for Maya, if you want to click on that, if you want to go to their actual website as well. Cool. Alright, so just to kind of rehash where these were on the actual shelf over here. We've got our it renderer just there. We're not going to open dynamic binding, but we've got a Pixar, our layered material Pixar. We've got our Pixar Disney. We're not going to worry about those. We've got our environment light. We've got our daylight. We've got our geo area light. We've got our geo area light blocker, which we can use for anything from stained glass windows to gobos to underwater caustics, or to use as light portals inside of for indirect lighting solutions for interiors. And of course we've got our make selected geometry emissive, which is basically just taking a piece of geometry into a light. And yeah, a few other options over here, which we're not going to really worry too much about. This TX Make, and I see to hover over them, I don't use them that often. Yeah, cool. We'll leave it at that. Okay. Alright, so that's pretty much it. What we'll do now is let's go ahead and just apply I'm going to go ahead and apply a Pixar Disney shader to my shader ball here. And again, you can apply it the exact same way that you guys are used to. You can right click, assign a new material, or you can jump up to your hypershade and create it that way. Or the shelf has given us a nice quick easy option just up here, create Pixar Disney. So I'm going to go ahead and whack that in there. Alrighty. Now I'm also going to just go ahead and just create a temporary light for now. Actually no, I'll go in and chuck an actual proper light in. Now I'm not going to explain this process just yet, as we'll be revisiting it soon, but essentially all I'm going to go do is plug in a rather low resolution IBL, just so I've got some dynamic lighting on my scene to kind of showcase what I'm actually doing. Cool. So what we're going to do is we're going to have a look at the actual Renderman settings, and I'm just going to explain kind of what a good portion of them do. I'm not going to cover every single aspect of these options because there's just so many of them, and I could be here for some time actually explaining them. Cool. Alrighty. Now I just want to point out over here, we're not going to worry about this little box in here, but just so you kind of know what's going on in case you accidentally click off on it, we have these 3 different options here. So basically these little or these two here, final and IPR, they're the kind of output values or output settings that we need to specify for rendering out render passes, etc. And one's for IPR, obviously, which we don't need. And one's for final, which we would basically, which the batch render would reference if we were going to do a batch render of a sequence of images. So if you accidentally click on one of those and you lose your global settings over here, just make sure that you select globals up here, and it'll give you access to this area, to all of the render settings, like so. Okay, sorry about that. I'm not sure when I had my mic mute, so I just kind of jumped back a few seconds. I was probably trying not to cough over the microphone when I muted it, and I didn't click it back on properly. So, okay, cool. So just quickly rehash what was going on over here. Renderman globals. Make sure you have globals up here selected so that you can access all of the quality controls that we're going to have a look at. These two over here are the kind of output values that we need to set for render passes and a bunch of other stuff as well, but we might not be going into that depending on how time goes. We may be able to kind of look at it. So globals is where we want. Now, I'm not going to go over the entirety of all of these globals. There's a lot of them in there. I'm not going to have a look at every facet of it just because, unfortunately, I just don't have time. So I'm going to minimize that, and I've just fired off a render like this with my IBL and my Pixar Disney shader, and it's gone ahead and opened up the IT window, which is this one here. That's a little bit dark actually. I'm just going to quickly increase the exposure. Probably shouldn't do it this way. Yeah, cool, that'll do. Awesome. So what I'd like to point out is when I hit render just then, it opened up this render view called IT. That's what I was explaining about before. Unfortunately, there is no way to integrate this with Maya, so I am going to be running out of real estate on my screen, and I'll do my best to keep it as tidy as I possibly can. There's no way around it. This is going to have to unfortunately sit over here somewhere or off to the side, and it's going to be a little bit awkward, but that's probably the only gripe I have with it. Other than that, it's absolutely amazing, and I think it's really worth using over the render view. Cool. Okay, where was I going? Alright, so we're going to have a look at the Renderman globals. Now I'm just going to minimize all of this stuff here. Now I'll explain what's happening in it soon, just kind of as we're working through it, what I'm actually doing. Alright, cool. So I'm not even going to bother looking at my workspace. I'm only interested in these two windows here. Actually, okay, cool. So Renderman globals. So having a look at our globals windows on the left hand side, I'll just jump into the Commons tab. The Common tab is exactly the same as what you guys are used to. There's no change. You can go in and you can specify your file format, change your prefix, your frame padding. Um, come down here, change your renderable cameras, as well as your output resolution, etc. So absolutely nothing different in this file here. Possibly there is one little difference, I guess, and that might actually be the color management tool, which I'm probably not going to get into for this class, so I'm not going to do a lesson on linear workflow, but I'll leave that for you guys to discover in your own time. In fact, I recommend checking out the Pixar website, where they've got an absolutely brilliant explanation on how it works. Cool, okay. So yeah, common tab is exactly the same, and all of the rest of them here are the same as what we can see over here. Cool. So let's jump over to sampling. Now I just want to point out there are two different sampling tabs. We have sampling and we have IPR sampling. So sampling is for our single frame render or our final output render or output quality, and IPR sampling is just for our IPR renderer. They're essentially the same with a few differences here and there. So I'm pretty much just going to have a look at some of the core functionality or some of the core settings in sampling, and just a couple of them in IPR, since they're basically exactly the same. Alrighty. So we can see straight away up the top we have our paths, where basically everything's going. We have our image size, basically what we've got our common set to at the moment. I've got mine set to HD 540. And below this we have our kind of information box, and essentially this is a nice way of just kind of visualizing the huge amount of rays that are getting shot into our scene. And it breaks it down from between camera rays and indirect rays, per pixel, max pixel, and the actual total amount. Cool. Awesome. Now below that we have our minimum samples, our maximum samples, our pixel variance, and so on. Now these are probably three of the key kind of quality settings that adversely affect render time, as well as overall quality. There's a bunch of other things down here as well, which definitely add to it. Other settings down here which add to it. Below that we have our integrator, which is, I'm not going to actually go into what both of them do, but basically it's essentially how your render is going to work, and we want to use path tracer. So I'm just making sure mine is on path tracing. Unfortunately I'm not going to cover both of them, but path tracing is really good for for directly lit scenes. You can still get caustics and stuff with it quite nicely, but VCM is good for a lot of like indirect scenes, and you get caustics for free. But from a lot of my testing so far, VCM, while it generally looks much more prettier, takes considerable amount more time to actually render, as opposed to the path tracer, which still looks absolutely gorgeous, but is a lot more straightforward, and you can tend to get things out much quicker. Cool. Yeah, cool. Okay. So let's go back up and actually start looking at what minimum samples, maximum samples, and pixel variance actually does. So, minimum samples. Minimum samples is the minimum amount of time a ray is going to sample a pixel on your screen. The maximum samples is the total amount of times it will actually sample a pixel. And pixel variance is basically a quality control between the two. Well, kind of. Basically, it's the way pixel variance works, and to put it in like a real kind of simple explanation, is that what it does is pixel variance controls when a ray hits a pixel and it looks at all the other pixels around it, and it goes, the quality is okay or the quality is not okay, or the grain and the noise is acceptable or it's not acceptable. And It's kind of, it seems almost a little bit kind of counterintuitive when you look at it like this, where the lower the setting, the higher the quality you're going to get, whereas the higher the setting, the lower the quality you're going to get, and it adversely affects render time as well. And we'll have a look at this very, very soon when we start doing some renders. Now, basically, how maximum samples and minimum samples works with pixel variants is that maximum samples, everywhere, as soon as you hit render, Renderman doesn't care. It's going to do its best to reach 512 samples until it meets the pixel variance, and if it's within the pixel variance where it's like, you know what, all the pixels around are acceptable, then it switches over to minimum samples, and then it will do whatever minimum samples you do. So it'll do 512 until it reaches that pixel variance, and then it'll do the last remaining samples. So minimum samples is currently set to 0, which essentially is the square root of maximum samples. So by default, leaving it at 0 isn't really a good idea. I'd always strongly recommend setting some sort of value. So maybe I'll even just start off with 2 for now. Actually, no, I'll leave it at 0 for now, because we'll fire off a render soon. Maximum samples. I'm just going to kind of show you guys again, explain this again, because it can be a little bit kind of confusing to understand exactly how it works when you first kind of introduced to the concept. Down here there is incremental render turned on. So what I'm going to do is on my renderer over here is I'm just going to fire off another render up there. Now I want you to pay attention to these little red boxes or buckets that are flowing from top to bottom of the screen. Because I have incremental turned on, we're going to see it render this way. Alright. You can stop your render as well if you're by pressing escape on your keyboard or pressing the cancel button up the top. If I was to turn off this incremental button over here and hit render, it's just going to do a one-off render, and it's going to slowly work its way through the different buckets. Give it a few seconds and you'll start seeing little, here we go. It will start rendering this way, one-off render essentially. But for the purpose of this demonstration, I am just going to use incremental. Alright, cool. So I'm going to lower my samples all the way down to 6, and I'm going to fire off a render. So maximum samples. Let's have a look at how this affects our render. So we want to count these buckets that flow down. We've got 1, 2, 3, 4, 5, and 6. And then it should stop. So it sampled my render 6 times. Now it did not reach the pixel variance, so it didn't need to fire off any of the minimum samples. So I'm going to go, actually I'll leave minimum samples at 0 for now. So cool. I'm going to go ahead and increase my maximum samples to 16, just so we've got a few extra arrays to, a few extra samples to actually work through. And what I'm going to do this time is I'm going to increase my pixel variance to 0.1. Essentially that is going to lower my overall quality, and Renderman is going to basically allow kind of more noise and grain in my render essentially. So if I fire off a render now, I want you to pay attention to those red lines flowing down. You'll notice them soon as they will hit that pixel variance, and they'll actually stop rendering. So let's see if it does that soon. Might have to actually increase my samples, my max samples. Now here we go, sweet. So you'll notice it's starting to skip some of the grey areas on the side here, but it's still focusing on the ball here, because all of this area out here, there's not much change in grain, contrast, noise, and all that. So it met that kind of variation in quality, that acceptable level, and then it hit minimum samples and did the square root of 16. So while it was happy with there, it wasn't happy with the ball. So you know, when it's finished with an area and it's actually met the max samples or the pixel variance, it'll only spend its time focusing on the areas that actually need it. So it's quite smart in that respect. Cool. So hopefully that's starting to make a little bit more sense for you guys as to kind of how it works, and I'll just rehash it. Minimum samples is the minimum amount of times it's going to sample a pixel and the pixels around it. Sorry, it's going to sample a pixel. Maximum samples is the maximum amount of time it's going to sample. Pixel variance is kind of like the acceptable level of quality threshold, kind of the acceptable variation in quality, and setting that to a higher value will allow more variation and allow more noise, more grain, and basically a noisier, lower quality render. And lowering that, it's going to be less accepting of kind of variation in all the pixels around it, resulting in a longer render but a much better quality render. So that is all good. So I'm going to drop that back down to 0.05, and I'm just going to crank up my max samples to 32. Alright, cool. So hopefully that's making a little bit of sense to you guys. Cool. Integrator, we kind of touched on that before. We're not going to worry about VCM, and we're only going to have a look at path tracer. So maximum path length. So maximum path length is the maximum amount of times it's actually going to go ahead and bounce around the scene. And currently it is set to 10. Now in my opinion, and it really depends on what it is you guys are trying to achieve, I like to set mine at 4 to begin with and then slowly increase it as I go. So just a bit of a kind of a I guess optimization process that I work through is 10. I believe is probably too high at the beginning, and some renders, particularly still renders, I can see very little to no difference between having it set to say 6 as opposed to 10. But essentially, it's how many times it's going to bounce around your scene, and the minimum amount of bounces that you should do with the max path length is 4, and that way you're going to get correct, semi-correct indirect illumination and stuff like that. So cool. So we have our different sample modes. We have manual, where we can go in and we can sample all of our different lights and specular and refraction, etc. manually, or we can use the BXDF method and just use the BXDF samples to sample it that way. We still have access to our light samples as well as our indirect samples. Caustics. Switching that on will turn caustics on. However, if you don't have anything that is not necessarily going to go cast caustics, don't turn it on. There's no need to. Cool. Awesome. Below that we have our max specular depth and our max diffuse depth. Now these are generally what we use to control glass and basically allowing light to penetrate multiple layers essentially. And set to 2, if you have a glass shader, it's going to be basically it's going to look like obsidian, a big kind of thick black piece of glass. So you do need to increase these settings here to basically start letting light penetrate through glass and for glass to start looking correct. As a general rule of thumb, I crank it up to about 4, 5 or 6 to start getting that light penetrate through glass, and my max diffuse, crank that up to about 2 or 3 as well, and then your glass should start looking like glass. But we'll definitely have a look at some of the base materials and jump back to these settings and crank them up to get them working correctly. I'm going to skip clamping for now. Russian roulette. Some of you are probably looking at that and going, oh, that's pretty cool, Russian roulette. Cool name. Wow. Essentially all it does is it just randomly culls the different paths that are bouncing around your scene. So what happens is after its 4th bounce, if it meets this roulette threshold of 0.2, then it's going to kill it. So that's essentially what it does. I'm not going to worry about holdout. Now I did skip this little part up here, pixel filter and denoise filter. I won't be covering denoise for now, but I'll explain essentially what it does. The denoise filter basically is a way of denoising our images. And it's actually pretty handy because you can reduce the render time quite considerably in your render, and it can actually remove quite a bit of grain and noise inside of your render. So you can actually lower your quality sometimes, and it will actually do a bit of the grunt work for you. Not always. So definitely check that out when you guys get a chance to do so. Cool. Probably the only other one that I really want to point out for now is filter, and that's where we come down to change our filter to, I don't know, something nice and kind of soft, or like a Gaussian, or nice and sharp like a Lancios. So that's where you access your filter that way. Cool. Awesome. So that's essentially the settings for sampling. And if I just bounce between the two right now, you'll see there's very little difference between the first kind of few options. All of these are the same between the two. Now, the only place where it gets different are the last options down the bottom for IPR. Is we have advanced, and inside of advanced we can just basically change the bucket order, the bucket size, and the crop window. Now, you guys probably heard me say bucket a few times. If you're probably wondering what a bucket is, when I hit render, so I'll just fire off a render now, these little these little red squares that are just flying or floating down the screen, those are what we call buckets. And we can change the order in which they actually fly around the screen, or sample our image via the bucket order. So you can change it to horizontal, spiral, zigzag, etc., etc. Pretty self-explanatory kind of what they do. Why would you do that? Why would you change the bucket order? Believe it or not, there's been working at a few big studios, we found that actually changing the way in which the bucket order rendered, we could avoid some things called ooms, or out of memories. Basically when the bucket order hits a very, very specific part of a very, very advanced render scene, and it freaks out, and basically the render wall, or it runs out of memory, and it just stops that frame, doesn't render that frame. And actually sometimes changing the bucket order approaches those pixels in a different way, and it can actually just push through and actually change how the memory output is affected, and essentially render. So but at our scale, we might not really ever need to change the bucket order too much, I believe. Bucket size as well is changing the size of those little red buckets, the bucket size. Now, increasing the size will, I guess, technically increase your render time, speed up your render time, sorry, but it will also chew up more resources on your computer. Having it too small will take a little bit longer to render, but you're going to use much less memory. So if you are running out of memory when you're rendering, maybe decreasing your bucket size or changing your bucket order might actually help you guys get through that, particularly if you have a very, very advanced scene with a whole bunch of craziness going on. Cool. Now, I'm not going to worry about the other options in that there. We're not going to go into those. Alright, I'm just going to grab a drink 1 second. Okie dokie. So let's just jump over to features. Here we can play around a little bit with our linearization of colors down the bottom here, which is for Renderman's kind of linear process. Just leave it turned on for now. It's not going to really worry us. It's not going to affect us for this workshop. I'm not going to really worry too much about this. We can turn on motion blur up here as well, if you want to do motion blur in your render, which is an option that we actually need to turn on for. Yeah, I won't go there. Cool, motion blur. That's all the motion blur settings there, and they should be exactly what you're used to if you are familiar with Mental Ray. Shutter angle, shutter opening, motion samples there for quality as well if they're coming out a little bit grainy. If we jump across to the Advanced tab, I'm not going to cover all of this here, But you might notice there's a few of these options similar to what we looked at in the IPR sampling. We've got our bucket size and stuff like that. Um, I'm not going to really worry about this. I guess lazy render is if you already have an image that exists on your hard drive and you're rendering out a specific frame and it exists, with lazy render turned on, it will just kind of ignore that. I believe that affects the batch render. I've never really used it for a while. I can't quite remember off the top of my head. Bucket order, the order in which the little rows, little red buckets fly around your screen, sampling your render. Minimum hair width, that is literally hairs, and it will limit limit the minimum width of those hairs. Grid size, not going to worry about. In fact, we're not going to worry about pretty much anything else in here. There are a few more options which you should probably look into. Shading rate, but basically that just kind of controls the general tessellation of your models every time you hit render, and that can sometimes adversely affect render time. But we're not going to worry about that just yet. Cool. And I'm literally just going to leave that all as is. I'm not going to go down to any of the other options. If I jump across to workspace now, basically it's just telling us where all of our Renderman files and data is actually being stored to inside of our project directory. So we can see we've got our project set up here, RMS project, D projects, PR man workshop, and then inside of that we've got Renderman, another Renderman folder, which is what we just looked at a little bit earlier. We've got our Renderman folder just sitting there. Cool. Alrighty, so that's kind of the gist of the Renderman controls, and we'll be bouncing in and out of here probably a few more times as we start actually working with things inside of our scene. Cool. Alright, let's just take a look at it since we've got it open, and probably some of you have been wondering why mine looks a little bit different if you're following along. By default, it should probably look a little something like this. Without all of these little options turned on. But inside of the Windows options up here, we can go ahead and we can just turn on basically all of the other little windows that are available. We have the catalog over on the left hand side here, and this is basically just a history of the different renders that you guys have done. So basically if you change a whole bunch of settings, you can kind of see them basically storing all of the different renders over there. And on the right hand side we have the inspector, which is specific to the different render that you're selecting in the catalog, and it gives you a little bit of kind of a little bit of information. It gives you like the telling us that we used a path tracer, maximum samples of 512, etc., and the render time took 15 seconds. Now the cool thing about this as well is if you need to take notes, you can go up here and you can say I did that and this, and it will just save those notes so that if you're wondering, like there's some of the little weird obscure option that you just tried just to test it out, you can go, oh yeah, cool, I did this, and away you go. So you can write notes in there as well, which is pretty handy. Now up the top we have our little kind of toolbar, our little drop down menus just above that. I'll explain these very, very soon. We'll actually use them. We have like our play button, which will actually play through the different frames. So if you're like doing a bunch of kind of like test still frames for whatever reason manually, which is painful, you can play through it. You get gamma control and your exposure control, which you can go ahead and you can go up a few stops if you want, entirely up to you. Also good for obviously testing to see if your depth is working. Cool. Down the bottom we have our inspector, which is like a little pixel readout, and it's just telling us all of the different pixel information, the RGB information is alpha, and the X and Y information. Cool. Alrighty, so up at our little toolbar over here, this little button here, that allows us to just kind of move our image around in our screen like so. If If I click on the next one, that allows us to left click zoom in and out, but to be honest with you, you should never really have to worry about selecting that. Selecting the pan tool and just using your middle mouse scroll wheel to zoom in and out is all you're going to need. It's going to save your time having to click on this all the time. Crop tool. Crop tool is what we want to use if we want to do, say, let's say a region render. So let's do a region render of this. So crop tool specifies the region, and then we can come up to image. So our image drop down menu, we can go render again, so we can actually render our images from it here. Or we can do auto crop render. Oops, sorry, I need to fire off the render. Maybe I need to just quickly set that. Of course it doesn't want to do it. There we go. Okay. So I just needed to redo it again. So I actually needed to specify where I wanted the render to work, like so. Cool. So let me just turn this off. Cool, and we can see that it's actually turned on. So if it's still doing that and you don't know how to turn it off, up the top here, just in all the menus over here, if there's a tick next to it, it means it's activated, and right next to our auto crop render, it's activated. So I'm going to go ahead and turn that off. I probably won't cover all of this because there's actually a fair bit. If we need to use it, I'll probably come back and use it. Yeah, cool. I think I'll just leave it at that, and we'll only use these on a needs and use basis. Cool. Okay. I'll turn off crop and go back to my pan tool. Alrighty. So what I should do is I will talk about the different lights that we have, and then we'll have a look at the Pixar Disney shader, and then we'll move on from the Pixar Disney shader over to the base diffuse shaders. Actually, I might apply to all of that. Cool. Okay, let's have a look at the different lights that we have available. Now I've already gone ahead and created a... Actually, what I might do is I might just take a quick 5-minute break and just grab a glass of water. Yeah, so if there isn't actually anyone watching this, I'm going to go have a 5-minute break, and I'll see you guys back in about 5 minutes. Cool beans. I'll see you guys then. And then we'll get into having a look at our lights. Senior Visual Effects teacher here at AIE Online.
Hi, my name's Ali and I teach the 3D Animation Foundations course.
My name's Craig Bentic and I teach Game Design Online.
Hi, my name's Sam. I'm a programming teacher here at AIE.
My name is Marcia Jürgens. I'm an animation teacher at AIE Online.
Hey, my name's Finn Spencer. I'm the lead online game art teacher for AIE Online.
Hello, my name is Michael. I'm Communications Coordinator for the AIE Online campus.
My name's Lee Michael. I'm the head of school of the AIE Online campus. We've worked together to split up the course into specific subjects so that people can then choose 1 or 2 subjects at a time and study at a load that suits them. So it fits in with their scheduling better.
So they're taught through a interactive live platform called Adobe Connect. It's great for students, it's online, and they can access it anywhere in the world as long as they have internet.
So I've worked on animated TV shows like Penguins Madagascar, Kung Fu Panda, Robot and Monster, and I've also worked on a whole bunch of blockbuster films like the Hobbit trilogy, Iron Man, Wolverine, and a few others.
I started in this industry doing in-betweening at Walt Disney Animation. I worked on movies like Aladdin and the King of Thieves and Little Mermaid 2.
My industry experience was working at a series of studios across Australia, primarily working as an artist.
Chronicles of Narnia, Prince Caspian movie. Back then in Germany at Scanline studio.
To make sure that AIE's content's relevant, we have to continuously have an input from the industry.
Everything we teach here is relevant to the industry. That's one of the probably the greatest things about AIE.
Join us on our next open day that's coming up soon.
Hey, my name is Ryan Ware. I'm the Senior Visual Effects Teacher here at AIE Online.
Hi, my name's Ali and I teach the 3D Animation Foundations course.
My name's Craig Bentic and I teach game design online.
Hi, my name's Sam. I'm a programming teacher here at AIE.
My name is Martian. I'm an animation teacher at AIE Online.
Hey, my name's Finn Spencer. I'm the lead online game art teacher for AIE Online.
Hello, my name is Michael. I'm Communications Coordinator for the AIE Online campus.
My name's Lee Michael. I'm the head of school of the AIE Online campus. We've worked together to split up the course into specific subjects so that people can then choose one or two subjects at a time and study at a load that suits them. So it fits in with their scheduling better.
So they're taught through a interactive live platform called Adobe Connect. It's great for students, it's online and they can access it anywhere in the world as long as they have internet.
So I worked on animated TV shows like Penguins Madagascar, Kung Fu Panda, Robot and Monster, and I've also worked on a whole bunch of blockbuster films like the Hobbit trilogy, Iron Man, Wolverine, and a few others.
I started in this industry doing in-betweening at Walt Disney Animation. I worked on movies like Aladdin and the King of Thieves and Little Mermaid 2.
My industry experience was working at a series of studios across Australia, primarily working as an artist.
Chronicles of Narnia, Prince Caspian movie. Back then in Germany at Scanline studio.
To make sure that AIE's content's relevant, we have to continuously have an input from the industry.
Everything we teach here is relevant to the industry. That's one of the probably the greatest things about AIE.
Join us on our next open day that's coming up soon.
Hey, my name is Ryan Ware. I'm the Senior Visual Effects Teacher here at AIE Online.
Hi, my name's Ali and I teach the 3D Animation Foundations course.
My name's Craig Bentic and I teach game design online.
Hi, my name's Sam. I'm a programming teacher here at AIE.
My name is Martian. I'm an animation teacher at AIE Online.
Hey, my name's Finn Spencer. I'm the lead online game art teacher for AIE Online.
Hello, my name is Michael. I'm Communications Coordinator for the AIE Online campus.
My name's Lee Michael. I'm the head of school of the AIE Online campus. We've worked together to split up the course into specific subjects so that people can then choose one or two subjects at a time and study at a load that suits them. So it fits in with their scheduling better.
So they're taught through a interactive live platform called Adobe Connect. It's great for students, it's online and they can access it anywhere in the world as long as they have internet.
So I worked on.
Alrighty, I am back. That probably wasn't 5 minutes, but so be it. Cool, okay. I'm just going to change my clipping plane. Why am I so blind? Cool, so I've already gone ahead and created a environment light, which is this big sphere around our scene. And that is how you basically, that's where you go to plug in your IBLs and stuff like that. So selecting it and having a look at the actual attributes. Up the top we have our shading rate. Now the shading rate is essentially the quality setting for lights and how kind of accurate they are. It seems a little bit counterintuitive as well, the shading rate, since we actually go the opposite direction to decrease our settings. So 1 is actually quite a high setting, so the lower the value, the more accurate the lighting is going to be, and the closer the light samples are going to take place, whereas all the light evaluations are going to take place. Whereas the higher the number, the more spread out the lighting evaluation and lighting sampling is going to take place, essentially not being as accurate but increasing render time. So anything from about 5 to 10 is well, 10 to 100 is a low setting, and anything from 1 down to like 0.01 is very, very high, but that will start increasing your render time as well, but you'll get much, much more accurate lighting. So that's essentially what shading rate does. So just to recap, the lower the value, the better the quality, the longer the renders. The higher the value, the less quality you're going to get from your lights, but the faster your renders are going to be. Cool. Okay, I'm going to fire up my IPR render up here, like so, just so you guys can kind of see what's actually happening inside of my scene. Now again, I am very, very strapped for real estate on my screen because I only have one screen, and it is basically takes up its own space because it's a floating window. You cannot integrate it with Maya yet. Whether or not they plan to do that, I'm not too sure. So unfortunately, it is like essentially a standalone window that will always float around. And if you only have one screen and you're constantly clicking back on Maya and it's disappearing, under the window option of it, there is a always on top, and that just means that this thing will always float on top no matter where you click inside of Maya. Cool. So I'm going to move this down here for now. Sweet. So the IPR render, as I float around, you can see it's basically constantly updating every time I move, which is pretty handy. Cool. Okay. Now I do have a reasonably crappy image used for my IBL. It's just a JPEG. You can plug in your HDRIs there as well and use those. I'd recommend them over JPEG without a doubt. Okay, cool. So moving down to the next group of attributes. These are very, very similar across all of the lights. We have primary visibility. Now if I turn that off, nothing changes inside of the renderer. Because when I mentioned a little bit earlier that every time we fire off a render, Renderman writes out information to what's called a rib file. And that rib file is readable, so you guys can go ahead and open that up in a Word editor of some sort. And you can see all the settings are very, very similar to what we have in our render options, as well as a whole bunch of other really advanced stuff. Now, I turned it off and nothing happened in my renderer. That's because I need to stop and I need to update my renderer. So that way it writes out the new changes to that rib. So if it does not exist in that rib, Renderman does not know to render it. It has absolutely no idea that you have changed something in the scene. I believe lights are fine. I can't remember off the top of my head. Changing certain color parameters are fine. Again, I can't remember off the top of my head, but if you change something in your render settings and it's not showing up in your render, stop it and restart it, and it will probably show up. Cool. Okay, so I turned primary visibility off, and as you can see, we can no longer see the environment. The environment's no longer there. However, it is still giving us all of the reflective and lighting information we had before we turned this primary visibility off. So technically it's still there, we just can't see it. So I'm just going to turn it back on, and once again we need to update the rib. So stop that render, escape or stop, and start that render again, and we should see it now. Cool. Exposure, just below that, exposure. Exposure is essentially our intensity settings. There is an intensity setting as well, which you shouldn't leave. It's now a legacy setting. Under advanced, you can see intensity. Just leave that alone. Don't touch that. Leave it as default. Just get used to using exposure. And exposure is our intensity setting. So if we go ahead and lower that, it gets darker. And if we increase it, it gets much, 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 much more brighter. Cool. Environment map image just below here. This is where you go ahead to plug in your IBL or your HDRI. And plugging it in there will basically just work exactly how IBLs should. Below that we have tint, and it, as well as the pop-up just said, it tints the environment color by this color. So if I put in something nasty like this horrible red, we're going to get that nasty, nasty, nasty red. So I'm going to go back to white and leave it as it was. Cool. Procedural color. I've forgotten what this actually does. Oh, my brain has gone blank. I'll come back to this when I remember it. Color temperature. Color temperature enables affecting the temperature of your image. So if I turn that on, we can go all the way to a nice kind of cold looking temperature, or we can dial it back down to a hotter, warmer red temperature. So that's another way that you can go ahead and tint your actual image. Sorry, yeah, we'll tint it with color, I guess. Component weights. Component weights are very similar to, if you guys are familiar with mental ray, the emit specular and the emit diffuse options that you have at the top of your standard mental ray lights, except these give us the ability to kind of control the overall contribution that they actually give to the scene. So currently it says specular contribution, it's at the maximum value of 1. If I go ahead and kill that to 0, we now have a completely matte image, because absolutely no specular contribution from that light is getting read or taken into account in the render. And we can go ahead and we can slowly increase that, start bringing those values back in if we want, but kind of a nice handy little debugging tool if you're not sure what the hell is going on, if you're seeing and you're getting some crazy kind of spec kicks going on. Or diffuse. If I kill diffuse, the complete opposite. Absolutely no diffuse information is getting taken into account by the renderer, because we've completely killed it, essentially. And we can also change it to red, so basically we can drive that color. You can, yeah. Just nice little kind of debugging tools. I guess another kind of handy way of looking at it is, say for instance, you want to cheat by having a light just kind of lifting some sort of dark area of your scene, but you don't want that light to kind of kick off any specular highlights on your characters or your environment. You could just say use, like, either minimize the amount of specular contribution or completely kill it altogether. Cool. Fixed sample count and importance. Fixed sample count is if you want to override the global way in which Renderman tweaks the sample counts for your lights. So you can do it on a per light basis by coming in here and changing these values. Importance is just changing the importance mode. We're not going to really worry too much about that for now. Blockers. Blockers is where we go in to create, well, blockers. We can use it to create portal lights. We can use it to create gobos. If we get time, we'll go through setting up some gobos as well, if we get time. As well as light portals as well, if you needed to, say, funnel some light in through from an exterior lighting setup into a dark interior. You can set up your portals via the blockers menu. Shadows, we won't worry about shadows. You can turn them on and off here, and there's a few kind of debugging kind of options. Shadow bias and stuff, shadow max distance, very, very similar to what you guys should be used to if you're familiar with mental ray. You can change the shadow color here if you want. I don't ever recommend doing that unless you have a very, very specific reason to do so. And advanced, we won't worry about advanced. And the last kind of last little nodes that you generally get with everything inside of Maya. Cool, so that's essentially the environment light. I'm just going to kill its exposure down to 0, so I'm going to make it a little bit darker. And I'm going to go ahead and I'm going to create myself a geo area light. I'm actually skipping the daylight currently. I haven't really played around with it that much. I have played around with it a bit, and it's very, very similar to that of the physical sun and sky, but I'm going to skip it for now. If we do get time a little bit later, I'll definitely have a look at it. Cool, so I created myself a environment light. I'm just going to move that guy up here like so, and having a look at that, we can see it's pretty self-explanatory which way you need to point it. There's a big giant arrow, can't go wrong. And by default, it doesn't quite work how if you use segment array, it's not going to quite work how you're used to, where increasing the actual size of it by default is not going to increase its intensity. There is a way we can actually switch that over to mimic that behavior. But if I increase that now, and I just open up my it again, alright, there we go. You'll notice this, the settings are pretty much exactly the same. There are some very, very specific settings for specific lights, but in this situation, majority of the actual settings here are exactly the same. So, we can turn on its primary visibility again. Once again, we'll have to stop and restart our render for that. Let's increase the exposure. So let me just stop and start that again. Do I even have the right one selected? I do. I have absolutely. Oh, there we go. Yeah, cool. So I was looking at it from the wrong side. I'm like, why can't I see that? Where the heck's my light gone? But it's just because I can't see it from that side. It's got backface. Essentially, it's got backface culling on. So if I look at it under there, I can now see it. So if I increase that exposure, we can now see it's taken effect. Like so. Color is exactly the same way. You can go ahead and you can plug in your color to whatever you want. Something atrocious like a nasty red. Color temperature works exactly the same. Nice hot colors or nice cool colors. Entirely up to you. Emission texture, you can plug in a texture to drive the actual emission. Obviously you got to turn it on here, and you can specify the actual resolution as well of the actual emission. Component weights work exactly the same, so we can kill that specular contribution. And we should no longer be able to see the actual specular reflection in the light, but if we were to crank that back up, we can now see it again. And diffuse, exactly the same thing. We can get that nice kind of highlight in there without all of the actual diffuse contribution. Cool. Sampling, exactly what I mentioned before. If you want to go in and you want to sample it on a per light basis, set to 0. It's going to just kind of use the global settings inside the render settings. Blockers, once again, blockers here, you plug them in. Now, I have absolutely no idea if they have fixed the blockers in this version. I am using, I think, 1.8, 1.7. I'm not sure what version of Renderman I have at the moment. I've completely forgotten. But blockers were a little bit kind of, well, they weren't broken, they just didn't hook up automatically. So hopefully that's fixed, so we can actually have a look at that a little bit later. Below that we have Spotlight. I'm going to skip Spotlight because, well, it's specifically for a spotlight, so when we change to spotlight we can access that. Light profile, we can plug in our lat long emission maps as well as our IES maps for like any form of kind of architectural lighting and stuff like that. If you've got any IES maps, you can plug them in there and away you go. Light distribution angle is kind of a way of redirecting or forcing the light angle in a specific angle, if that makes sense. So you can kind of force the way in which the light kind of angles outwards via the light distribution. Distance is specifically for distance. Barn doors, I'm pretty sure we can use barn doors for this. Barn doors are the little flaps that you see on the side of spotlights, say on a set, designed to just kind of like block out one kind of side, and I think it does work. Let me just turn it on. Yeah, cool, it does. Okay. Bundles, we can go and you can see now it's created the way in which our light is displayed in the viewport. And that just allows us to kind of come in and block light from whatever angle we need, like so. And we can see over here is blocking that light. Shadows are the same, advance is the same, except it does give us a new option. We have a button there called normalize. And normalize will basically normalize the light so that it acts how you might be familiar with if you are a Mentor A user. So if I turn it off, it's going to be ridiculously bright. So let me just drop this exposure back down to 1. And actually the scale of the light will kind of alter the actual intensity of it that way. So I'm going to go down and just leave it turned on. Cool. And yeah, that's kind of it for the area light. Now, to access all of the other kind of lights that you might be used to, there is the shape node. Now, I purposely skipped this beforehand, but if I click on that, we get a little drop-down menu. You can see we've got our distant light and we've got our spotlight, as well as disk, sphere, and cylinder. So disk, sphere, and cylinder essentially act very, very similar to the rectangle or the area light, except they are in the shape of a disk, sphere, or cylinder. So I'm not going to really look at those ones, other than the fact that they change the way in which they change the shape of the actual area light. Really, the only two other ones that are mostly different is distance and spotlight. So distance is essentially a directional light. So it's a constant direction of light. So if I crank that up, now why did you not update? Okay, it's not actually updating. I just decided to be difficult. Let me just create a new one. Actually, let me just... Wow, okay, I have no idea why mine is not actually updating. Let me just stop and restart my render. Yeah, okay, there we go. So I needed to stop and restart my render with that light specifically, which makes sense now. Okay. Stop, restart. Cool. So just think of it like, you know, light that mimics that of the sun to a certain degree. It's just a constant directional force of light. And all of the settings are exactly the same for this one. Nothing new. I'm not even gonna. Yeah, cool. That's pretty much it for that light. Nice constant direction of light. And lastly, we have spotlight. So if I change that, stop and restart my render. It is a spotlight, and it works exactly like the spotlight you guys are used to. And if we come down to the spotlight specific options, we have cone angle, penumbra, and penumbra exponent. So we can change the cone angle to what we want. We can change the penumbra of that cone angle, basically softening the essentially the fall off of that spotlight. Unfortunately, you can't really look through it like you guys are used to. You kind of can, but it doesn't really work. I know there's a pretty good script on the there's a good script on the Pixar website that you guys can download. So basically, you can mimic that if that's really a key feature that you need. You can do that, and penumbra exponent as well. Exactly how it used to work. And of course, the color and color temperature and all of that good stuff works exactly how we are used to. Cool. And that's essentially it. Those are really the kind of the key lights. Well, they are essentially the key lights that we need to use for that one. Now the next one that we have, I'm not going to go into blockers just yet, is our emissive light. So I'm just going to go ahead and delete that spotlight, and I'm going to come down to the sky. I'm just going to really underexpose the area light. And I'm going to go ahead and just select some random geometry on this guy. Maybe I'll select inside here. And I'm going to go up and I'm going to click on Make Selected Geometry Emissive. Cool. And so essentially that's gone ahead and applied a shader to it, which gives us the ability to turn that light into, well, that geometry into an emissive geometry. So I might just give it a reasonably cool, prettier looking color. Crank up the exposure. Let me stop and restart that render. Yeah. We can go ahead and create neon lights and stuff like that. Now, if I am correct, hopefully I am, they recommend using this over actually the emissive parameters and shaders. I think this one's more optimized for, I'm not sure what. It definitely has a lot more options. You have the ability to control it a lot more. You get to control the actual shading rate of it, the exposure, the color, the temperature, the specular, diffuse, contribution, shadow angle, and distribution angle. So basically it just gives you a lot more control than if you were to just turn on a single slider for emissive properties in an actual shader. So you can go ahead and use it like that. All pretty fun. Cool. Alrighty, well I'm going to kill that just because it is quite an expensive render. So I'm going to go and assign my Pixar Disney back, which is a nice grey. Stop. Crank up my exposure back to 1. And back to where we were. Alrighty. What we're going to do now, we'll have a look at the Pixar Disney shader. Cool, so that's essentially it for lights. Obviously there's quite a bit more that you can do with them. And if we get a chance later, we'll have a look at blockers. But what we'll do now is we'll have a look at the Pixar Disney shader parameters. And then we'll move on to the LM diffuse, LM layered materials. Play around with those. Cool, okay. So let's go ahead and I'm just going to apply a different Pixar Disney to that one. Nice blue one. Give that a render. Cool. Alrighty, let's have a look at the different attributes that come along with the Pixar Disney shader. So the Pixar Disney shader was developed by Disney. It's a semi-plausible shader, designed for ease of use with values of 0 to 1, but you do have the ability to overdrive the properties where appropriate. So 0 to 1, the sliders are just on that range, 0 to 1 like so, but if you need to overdrive it, you have the ability to do so. Cool, okay. So starting at the top, we have a base color. Base color is essentially the diffuse color, and that is where you can plug in your diffuse textures if you so decide. And you can go ahead and you can play around with the colors as you see fit. Emit color. So emit color is the emission like we just looked at. Now once again, if I crank this up and we fire off a render for that, it's going to be emissive. But notice we have absolutely no control over the quality of it. We have no other control over it like we did with the actual make geometry emissive. So it's recommended not to use this one. So I'm going to turn that off by dropping that back to black and leaving it as that. Subsurface. Next option down. So this is a fake subsurface, or an approximation of subsurface. I can't quite remember. It's not true subsurface scattering, but it still looks really, really nice, and you can get some absolutely fantastic results using it. So that comes with two different parameters. It comes with subsurface and subsurface color. So the first one, subsurface, 0 to 1, controls how strong the subsurface actually is, and subsurface color below is the color that is going to basically start transmitting through or bouncing through from behind. So if I grab that and I grab like a pink or something, that'll look nice and blue. And if I go ahead and just crank that all the way to 1 and fire off another render, you can see that it's essentially pink, but we're still getting elements of blue coming through. That's because our subsurface is maxed out. However, if I drop this down to say like 0.5, render that out again, it's a little bit strong, but we can definitely see some of that blue base diffuse color starting to come through in the middle. So if I drop that down to 0.2 now, we start getting that nice subsurface kind of effect going on with the, particularly around the edges where we would expect to see it. We're getting that nice kind of pinkish haze or pinkish kind of subsurface scattering through along the edges. Cool, okay. Now below subsurface color, we have metallic. And metallic is, once again, 0 to 1. 0 being a dielectric material, 1 being a metallic material, and obviously anywhere in between. So set to 0, it's not going to act like metal at all. Set to 1, it's going to be a metallic object, which means that our specular color is going to start being tinted towards the base color the more we increase this setting. So a little bit hard to see. Let me just create an area light above it just so we've got kind of something to see what I'm talking about. Might just increase that a bit more. Not that much. Cool. Okay, so metallic 0, dielectric 1, metallic, and obviously like metallic objects, as we start actually increasing the value of it, and I'm just going to go straight to 1, we're going to basically get a full metallic object where even the specular color is tinted to that of the base color of the material, like so. And I believe we're still getting just a touch of our subsurface through. It's nowhere near as strong. I think I can see it. But I'm going to drop that down to about 0.5. Why not? Just make it look like an interesting shader. Cool. Specular is how shiny or how much specular value is on our object. Set to 0, it's going to be a matte object, no reflective property whatsoever. Set all the way to 1, if I render that out again, a very, very shiny object. Specular tint. Now I'd have to just kill metallic for this actually, so I'm just killing the metallic property. So specular tint basically is going to start tinting any of the specular color towards our base color. So if I was to crank that all the way to 1 and render again, just paying attention to that specular highlight there, it's basically tinting it towards our color, our diffuse color. Roughness. Just below that we have roughness. Roughness is essentially how rough the surface is, how porous it is, basically how much kind of light is absorbed into it. Currently it's set to 0.25, which is quite low, which means we've got a slightly kind of ever so slight bit of glossy roughness to our material. If I was to crank that all the way to 1, it is going to be a completely matte material, similar to if we were to kind of kill specular to a certain degree. Very, very rough. There are still specular properties in there, but because of the surface being so rough, think of like chalk, brick materials, or if it was glass, it would be frosted glass. So roughness basically describes the roughness of the surface. So I'm going to drop that back down to 0.1. Anisotropic is basically the way in which the reflections and specular bends on an object. If you guys are familiar with brushed metal, or say CDs, the way in which the kind of the reflective specular properties bend on those specific surfaces, that's exactly what anisotropic does. Essentially bends it. Now it's not really going to make too much, it's not going to do too much here. Let me just try. Oops, where am I going? Just put 0.1 on there. Let me fire off this render. I don't think it's going to make much of a difference here. Yeah, no, don't worry about it. We'll leave it. But that's essentially what it does. And we can control this in other shaders a lot better. We can actually go in and specify it at a greater detail. I'll leave that as is for now. Okay, I might just increase that roughness because it's very, very shiny, very, very smooth. Just a little bit. Let's just go to 0.25. Oh, 0.25 rather. Just so we can have a look at sheen. So sheen, the next one under anisotropic is it's essentially like a second specular lobe or a second specular property. Most commonly seen in materials like silks and velvets and stuff. It's almost like a glancing angle reflective property. And it's not going to really make too much sense just here, so I'll have to kind of bounce between two different images. But if I crank my sheen all the way up to 1, I am not sure what's going on. I think I might just have to quickly kill Renderman. I think Renderman's freaking out just a little bit. Where am I? So I'm just going to see if it just corrects itself for a second. It probably won't. I might just... Yeah, I'm probably going to have to kill it. Okay, cool. Yeah, I just had to kill it, unfortunately. I just literally killed Renderman just then. So if it just kind of locks up and it just sits there, and you're not sure what the heck's actually processing down there, you can just go into your Windows Task Manager and just kill the PR man process, and it should hopefully free itself up for you to carry on. So hopefully it hasn't broken anything too much. So where was I? Sheen. Let's go ahead and crank up sheen all the way to 1. And I'm going to go ahead and render that. And I'll just let it render out a little bit more. And sheen is really the glancing, it just adds like another specular phenomenon or specular sheen on essentially the glancing angles of your object. Now, it's not going to be that noticeable right now because you kind of saw it, like you haven't really got anything to reference. But if I was to go into it and say bounce between that one here, yeah, we'll have a look here. Did I increase sheen? Yep, cool. What I'm actually going to do is, I don't know if I turned it on that one. What I'm actually going to do is I'm going to turn on background layer. So I'm going to select my last render and I'm going to click on this button over here, which is toggle background layer. And I can see that my background layer has now been activated. So this one here, because it's got like a little red highlight around the eye. What I can do now is I can select the current render that I just rendered, and I can come up to this tool up here, this tool over here, wipe tool, and I can just kind of wipe between it. And it's a little bit hard to see, but it's essentially adding like another layer of speck along this kind of glancing angle here. And I can actually emphasize that more by tinting my sheen. So if I grab my sheen and I tint it more towards the blue, hopefully that'll work. Let me just crank the sheen up even more. Actually, I'll completely overdrive it. So you can see where it's essentially taking effect along the edges. Now I did really pump up the actual property. Probably shouldn't have done it that much. Probably 2 would have sufficed. So I'll just let that work itself out for a second. Cool. So hopefully you can see exactly what's going on there. So I'm just going to lower that sheen down, cancel that render, drop that sheen down to 1. Yeah, sure, why not? I'll leave the sheen tint on. It's starting to look like quite a funky looking shader. I am going to make sure that I turn off my toggle background because I can still see that this specific render here is turned to red. It's still got background toggled on, so I'm going to go up here and I'm going to click on the toggle background back off, and we can see when it's on because that little bit turns grey, and off because it's no longer grey and there's no longer a red highlighted eye. Cool. Alrighty, below that we have also clear coat. Clear coat is basically another specular lobe over the top, used predominantly in car paint, and clear coat gloss controls the glossiness of the actual clear coat. Below that we have bump node. And the bump node is where you guys can plug in your bumps or your normals. So we can go ahead and let's just plug in let's do a noise for now. So let's go to the checker icon and select, let's just do a noise, let's do a fractal. So I'm not even going to bother changing any of that, I'll just render it as is. And bump works exactly how you would imagine. It describes, or I want to say interpolates the surface. I can't remember. But yeah, basically it describes the texture of the surface. And if we jump over to the hypershade or the actual node editor, so the fractal that we created gets plugged into our Pixar Disney shader, and we also, by default, it goes ahead and plugs in the bump 2D node, and the bump 2D node works exactly the way that we used to. And you can tone it down, you can crank it up, you name it, you can do whatever you want with it. Exactly how you guys are used to if you're familiar with Renderman. Sorry, Mental Ray. And of course, just below that, you can also change it to normal tangent space as well. And a little drop down menu just below that, and take it from there. I'll just crank up that bump. Cool, okay. So bump works exactly the same. Now we do have one option down below called presence. That is essentially a cookie cutter. It controls the opacity of our object, and we can go in and we can plug in a mask, black and white 0 to 1 mask, to control where it's actually visible. And we can demonstrate that by literally plugging in a checker utility node like so and firing off a render. And that goes ahead and just cuts the actual object out like so. So good for, say, leaves or something like that on a tree. Cool, cool. And I guess there is actually one more little section just down below, and that is the input AOV. The input AOV is where we plug in our mat ID nodes to basically assign different mat IDs to our objects for our mat ID passes. Cool. Alrighty. So that is the Pixar Disney shader. I guess what we'll do now is we'll have a look at some of the base materials that come with Renderman. So let's go ahead and assign a new material. I'm actually going to do this via the Hypershade this time, so you can just have a look at the different materials that we have available. So under Renderman RIS, we have our base materials. Now you'll notice Pixar Disney is not in there because these ones are actually layered materials. These ones give us the ability to daisy chain a whole bunch of layers together. They can be found under the materials tab. The Pixar Disney can be found under the material tab just over here, as well as constant light emission and a few other bits and bobs, our volume as well. A whole bunch of different patterns and utility nodes that give us a whole bunch of functionality. There's even a Renderman specific texture, Pixar texture node here, which is very, very similar. File name, you can plug in, change the filter, blur it, tells you missing color, and linearize your actual files that you're piping in through it. As well as plugging in a manifold, which is very, very similar to, say, our bump 2D node. If we were to create a, let's go up here and just create a fractal manifold, very, very similar to that of the place 2D node. Not quite, but we can offset it and stuff like that, and where we go. But it's almost the same. So base materials, that's what we're going to be looking at. We're not going to worry about the rest of it. And we're just going to have a look at diffuse, glass, metal, and plastic. We're not going to be going into subsurface for this session. Cool. So let's start off and have a look at the Pixar LM Diffuse. And I'm going to go ahead and apply it to this guy here. And let's give that a render. Where's my Cool. So our diffuse, let's have a look at the different options for that. Let's just cancel that render. Okay. So having a look at these different properties here, we have overlay at the top. Now we're not going to get into that just yet. We'll have a look at that when we get to the metal shader, or one of the other shaders. But that's basically, if we click on that, it's automatically going to start setting up a layered shader system, and it'll apply another material, another shader over the top of this one. Front and back color gives us the ability to shade both the facing normal and the other side of a single polygon plane. So you can, shade both sides, and we can kind of see that actually happening if I just go ahead and just, sorry, not a bump, I was going to plug in a checker to my Disney, and I'm just going to paint the back color red just so we can see exactly what's going on here. So it gives us the ability to basically color or texture both sides of our faces of a single face. We go ahead and break that connection. Oops, presence should be 1. Okay, cool. Diffuse roughness, exactly the same. It's the roughness of the diffuse. Cranking that up is just going to make it more rough, essentially. Sheen, exactly the same as what we saw before. It's like a secondary kind of specular property to it. Below that we have translucency. I might just change that sheen color to something really obvious. So you can see that pink value coming in around the sides like so. Cool. Below that we have translucence, and basically what translucency does, or translucence does, is it drives, or basically essentially it makes this shader translucent, and our back color that we specify will start basically coming through the front color. So if I slowly increase this, let me just turn on my IPR render this time. Currently I'll just slowly increase it. Basically it turns into a translucent object or shader. I crank it all the way up to 1. We start getting that value pushing through the surface. Incandescence makes it glow. Once again, we should be probably using the make selected geometry emissive, basically using the emissive geometry up there as opposed to there. Bump works exactly the same, and presence works exactly the same. Cool. Alrighty, I'm going to go ahead and apply our next LM material. So assign new material. I'm going to go and apply a Pixar LM glass. Cool. Okay, so I mentioned earlier at the start of this class that glass is really, really dark because there's a few settings that we need to play around with. One of them is the diffuse and specular depth. So by default, it's really, it's dark. It's a dark piece of glass, and we need to crank up those settings. But actually, so let's actually go do that now. Let's come to sampling, come down to default ray depths. I'm going to crank this up to like 5 and 2, just for starters. Cool, that's starting to look better. And I probably just need to keep cranking that up. Now, probably doesn't help that I have another object inside kind of blocking light. If I was just to move that out, let's have a look. Yeah, there we go. So it is working fine. It's just I've got that kind of that solid piece of geometry and they're making it look darker than it actually is. So it is working fine. So I'm just going to move this. Cool. Okay, back to the actual material itself. So I might even need to crank this up a little bit more. I'm probably going a little bit too high. Yep, no, that's starting to look nicer now. Cool. Awesome, so we have glass. And for this one, I am actually going to apply that, turn that piece in the middle to glass as well. Just so we can get that light, really get that light in there. Now it's just very, very confused with what's going on in the scene because there's multiple different layers of stuff going on in there. Might get rid of that. And there's a lot of multiple reflections going on, so it's quite an odd piece to work with. That's okay. If I let it render, it'd probably start making sense. Cool, let's go back to the shader. Cool, so we have thin at the top. This basically changes how it works. If we don't have it on thin, basically it doesn't bend light in any way, shape or form. The refractive index doesn't come into play essentially. So if I turn thin on and give this a render now, it will just basically look like really shiny layers of geometry or transparent pieces of geometry, which is cool. But if we turn it back on, or we turn it back off, it's going to basically start bending light or refracting light through the actual solid pieces of glass. Cool, below this we have our refractive index. Now I'd just like to point out this little drop down, these little two arrows here. Clicking on that will give us the actual I'm pretty sure it's the average or close, or some of them are exactly accurate index of refraction for very, very specific things, ranging from acrylic down to vodka, oil, nylon, milk, and so on and so on. So if you guys actually know what material you're working with, by all means, I strongly recommend using these presets because, well, generally they're quite accurate. Now, I'd just like to point out as well, I mentioned earlier that presets can be accessed via the preset menu, exactly how we're used to. Up the top here, we've got our different types of presets: architectural glass, crystal, default, depression glass, etc. I might actually chuck some depression glass on there, get it nice and thick looking. Maybe I won't go depression, that's probably a little bit too much. Maybe we'll go crystal. Let's have a look at that. Yep, cool. So definitely play around with those, get a feel for what they actually do. I'll leave it back at default. Cool. Roughness. Roughness we can increase if we want to give ourselves that kind of frosted glass look. So I'll give this a render now. It's basically going to give us that frosted glass look. Cool. Awesome. Okay. Below that we have absorption, and absorption is literally how much light it's going to absorb into our object. So if I crank this thing up to like 0.3 and give that a render, it's going to basically be much, much more darker. Cool. And we can actually come down here and change our transmission color as well. Let's do a red. Maybe I'll drop my absorption down to like 0.1 for now. Fire for red. we can make some kind of nice thick tinted glass, I guess you can say. Let's put that back to 0.25. Maybe I'll change it to like a blue. Maybe a bit too much absorption. Cool. But you guys get the idea of what's actually happening, hopefully. Cool, it's kind of working, kind of. I'm going to kill that as well. Transmission color, if left by itself, is basically how we would tint it. So we do need a tiny little bit of absorption in there. Let's just try this. And we can see that it's starting to absorb that color in the actual glass itself. Cool. Awesome. Okay, below that we have shadows. Now, thin shadows is ideally I'd probably use thin shadows if I wanted to get away with not using get away without an expensive caustic render. Now it's not really going to make much sense here. I suppose if I was to create a simple ball, why not? Why not? Just going to throw a light over the top of that just so we can actually see what's going on. Cool, not going to make much sense now, but if I was to grab that glass and I was to turn shadows onto thin, hopefully it will actually be able to see it. I might have to move a little bit closer. It's not working how I thought it would. But basically, it should work how I thought it would. Essentially, what we use that for is just kind of faking that kind of caustic effect of light kind of coming through a glass, and it will essentially do that. It probably is just going to take a bit of time to render, but that's generally the only reason I would use that for. It is actually use that for, yeah, kind of faking it like that. Cool, and that's pretty much it for glass. Bump is bump, presence is present, input AOV is input AOV. Cool. Alrighty, let's go ahead and let's assign a new material, and this time we will go with. We'll skip metal and we'll just jump down to plastic for now. We'll just finish off with metal. Actually helps if I use a proper shader that has everything. Cool. Alrighty, let's fire off an IPR. Cool. I always find plastic is probably the most diverse shader to use. We have a lot of different properties that we can play around with if we have a look at the actual samples. Now I'm not going to cover every single one of them because there's quite a few. Diffuse is diffuse. A lot of the settings are the same. Roughness, translucent, sheen, incandescent, bump, all the same. Specular, color, roughness, anisotropy, refractive index as well. So we can go down here, we can change the refractive index to a very specific type of element. We've got bump, and we've got a shading tangent which controls the direction of our anisotropy. Clear coat is clear coat, adds like another specular lobe over the top of the actual shader, mimicking that essentially of car paint, etc. As well as down here we've got our presence once again and our import AOV, and this one comes with a bunch of really nice presets that you guys can actually go to straight away. I have no idea. Let's have a look at that metal foil. That is atrocious. Let's go clay. Cool. But if you guys do actually know the type of material that you're working with, and it contains similar or exactly the same kind of visual properties as what you see up here, there is absolutely nothing wrong with going to these actual presets to begin with, because they're actually really well tuned. They work exceptionally well out of the box, and then you can just tweak it to what you need from there. So don't hesitate to definitely kind of jump in there and actually play around with them that way. Cool. Okay, well, we've been going for like another hour already, so I'm going to take another 5 minutes break, and we will basically kind of come back in, well, roughly anywhere between 5 and 8 minutes time. But well, I will be back in 5 minutes time anyway. So what's the time now? We'll make it 8 past. Cool. I'll see you guys soon. Alrighty, I am back. Hopefully you guys can hear me. I'll make sure my mic's actually on. Cool, okay. Alrighty, so that's the plastic shader. Let's jump over to the metal shader now. Let's move this guy off yonder. Let's go ahead and apply ourselves a base material metal. Cool, so having a look at the properties that we have for metal, we have our refractive index and our extinction coefficient. And both of those come with a bunch of really, really good presets, which I strongly recommend using if you know exactly what it is you need. There's also a bunch of presets which you can go for up here as well, which work really, really well. Roughness is the same, anisotropy is the same, specular color changes the specular color. I'm not sure if my microphone is working. I'm just testing to make sure my mic's actually working. Might have a few technical issues at the moment. Cool, okay, it's working, fantastic. Cool, okay. Alrighty, let's stop and restart that. Cool, okay. Let's go ahead and actually have a look at what overlay does. So, overlay is what we use to essentially daisy chain ourselves or create ourselves a bunch of layered materials. Now if I go ahead and select overlay and click on it already, boom, it automatically updates the shader. It goes ahead and it hooks in a layered material. So if I go ahead and open up my node editor now, we've got our Pixar LM material and we've got our Pixar LM metal and our Pixar LM layer. Now essentially what our layer is doing is it's applying another set of shader properties over the top of our layered material. And if we have a look at the different settings that we have for the layered material, sorry, pardon me. Up the top we have overlay, so we can basically daisy chain our layers up to, basically it enables us to create a whole bunch of really complicated layered materials. Below that we have diffuse, specular and clear coat. Now you'll notice all of them have little kind of enable buttons up above them, and basically that's just turning on or off those specific properties. So if I turn on diffuse, so we're back, basically I've turned them all off, so we're back to our base metal material. Now if I turn on diffuse, it's essentially going to coat it again with another diffuse, and if I turn on specular, it's going to coat it again with another specular, and clear coat is basically going to turn the clear coat on. Now we can go ahead to, well actually to be able to control where those are visible, we need to go up here and we need to create ourselves a layer mask, and we can kind of see this taking effect by just plugging in a checkered material like so. And we can see straight away it's just masked out our metal material with the new layered material sitting over the top. So essentially that is the main kind of control factor or the control mask that we need to make sure that we input to get the properties visible where we actually need them. Cool, okay, let me just go back to my layered material. Awesome, okay. So this allows us to basically create a whole bunch of really, really cool layered materials. And this is a really, really fun material to use, and we can create a bunch of awesome looking stuff. So I guess what I'll do now is I'll just kind of quickly show you guys. I'll go ahead and I'll plug in. I'll add some rust to this actual object now. So I'm going to just break my layer mask, and I'm actually going to go ahead and I'm going to plug in a. We can either use file texture. Renderman does really prefer its own Pixar texture down here, but if you're doing really simple stuff, this I've found no reason not to just use this one if you're more familiar with this. You do get a fair bit more control using the Pixar one, but for simple shaders, plugging in simple things, I really don't care about using the file texture. It works how I like it. It gives me a few controls that I'm familiar with, and it works. I'm okay with that. So I'm going to go ahead to the image over here, and I'm going to go ahead and plug in a mask. Sorry, just had to grab a quick drink of water before I started coughing. Where am I? Jump over here. So I'm going to go and plug in my layer, and I'm going to browse to a mask. I probably should have organized this a bit better. Oh well, I don't think I actually have it. Let me just test this one out. Let me stop and restart that render. Come on, start rendering. Actually, I do have it. I know exactly where it is. And I plugged in the wrong one. Let me just browse to the location. I thought I put it in there and I didn't. Oh gosh, okay, maybe I have actually hidden it. So bear with me in un momento. Cool, so I've got my mask here. I need to go ahead and plug that in now. Cool, let me restart that. Cool, okay. So I've got my mask basically telling me where I want the new layer to be visible, and I can see it quite clearly now. And here I can see this is the new layer material sitting over the top of it. It's been masked out correctly. So I can go to, once that's stopped, I can now go ahead to my diffuse, and I can actually plug in the rust diffuse that I actually want. So I'll grab that guy and I'll go ahead and plug him in. And basically that essentially demonstrates what it is we need to do. Now I haven't actually got a proper spec map painted up for the actual rust, so I might just quickly turn that off for now, just so it looks a little bit better than what it already is. So I don't want any specular on that layer. I can see that it's using this, basically it's just a generic complete coat of spec. So if I turn that off and just get that another render, it's going to look more prominent. It's going to make the rust look more prominent. Actually no, sorry, I do need that on. Yes, I will leave it on. And you know what, I'll just leave it like that. I could even probably just be quite cheap about it actually and just plug the same diffuse map into the and just use that to drive it. I have no idea who put that there. That's not mine. That's someone else's. Terribly sorry. Yeah, I'll just plug that in there and I'll use that to drive the spec. Whoops. Cool. I make no excuses. There we go. Cool. And I'm just using that to drive the spec a bit better because I didn't have a spec map to actually drive it. And obviously, it's quite a low quality render, but if I was to let this just render over time, it would probably look really, really nice. And then that's essentially how you start building up your layers. Now, I probably would have put a lot more care and time and effort into my my layers, but that generally that essentially highlights what it is I need to create, or what it is you need to do to basically start creating your layered materials. Sorry. Anyway, cool. So that's the layered materials, and basically you can daisy chain that to the cows come home and create a whole bunch of really, really advanced textures, and it looks really, really cool. Yeah, cool. So that's the layered materials. Fantastic. Cool. Okay, so that's essentially it for the layered materials. Now, I'm just trying to think about what I can squeeze in. I really only have about 40 minutes left. I might just quickly show you guys displacement. Don't have enough time. Do I want to do displacement or AOVs? You know, I might just quickly show you guys how to do some basic AOVs instead of displacement. No, I'm going to do displacement. Displacement always looks cool. Okay. Alright, well I'm going to grab this guy and I'll just duplicate him off yonder. Not that way. Come here. Set him over there. And I'm going to go ahead and I'm going to apply, I was going to use a Pixar Disney for this, so I'm going to assign a new material. I was going to go Pixar Disney. Now, I am being a little bit rushed. I would always recommend it to everyone, name your shaders, name your objects. Naming conventions are huge and very, very important. And I haven't done that for any of my shaders, so that is a bit of a messy workflow. So I'm terribly sorry about that, but I would usually do it if I wasn't in a rush. Okay, so I'm going to go ahead and I'm not going to use a tangent space. I'm just going to use a my brain's failing me at the moment. Vector displacement. Cool. Okay. So I'm going to displace this, and I'm going to use a rock texture that I have set up. So I'm going to go into the shader properties. Actually, I'm going to go into the where do I want to go? I want to go to the node editor. Actually, no, I should probably use Hypershade. Make it a bit easier. Cool. So I've got my Pixar Disney that I've applied, and I want to access the shading group, which I automatically have right here. And to basically apply a displacement material, it's very, very similar to mental ray, is we need to use the displacement material slot over here. But instead of applying the default one for mental ray, we need to come down to the displacement filter area over here, and we need to plug in an RMS displacement like so. Cool. So that's plugged in where it needs to go. Cool. So I've got my displacement here, and just having a look at the attributes for the actual displacement editor. Now, it's not like mental ray where we have to go in and muck around with a whole bunch of, where are we? Do I have mental ray? We don't have to go into the approximation editor and do a whole bunch of stuff there. It's basically we just need to whack on a couple of attributes. I can't remember if it's to the shape node or if it's to the shader node. I'll find out soon. But we don't need to worry about the approximation editor. We just basically need to deal here, basically work in this area here and apply an attribute. I think it's to the shape node. My memory's failing me right now. But anyway, Shading rate is exactly the same. The lower the quality, the better basically essentially the better the quality displacement you're going to get. Obviously, the lower, the higher the lower the number, the better the quality, but also the longer the render time is going to be. So always remember that. Displacement bound is essentially a limitation to how much the displacement can bound to or how much it can displace to. So leaving that or setting that to a too large a number is going to basically soak up more memory, and you don't want to use too much memory. So you generally want to make sure the displacement bound is set to something quite low. So I'm going to leave it like that. Dice restoration, I'm not even going to worry about that. And disable disables it, obviously. Mask masks your displacement if for whatever reason you need a mask. Cool. Displacement mode, we have scalar. Sorry, I said vector before. I'm actually going to be using scalar, sorry. We're going to use scalar, but as you can see, it's already got some kind of presets to Mudbox and ZBrush that work specifically for their output settings and their output methods. So if you're using a ZBrush displacement, tangent, object, or world, away you go. You can see exactly where it is and what you need to select. So I'm just going to be using scalar. Now, I'm not going to worry about displacement encoding. I'm not going to cover every single aspect here because we don't really need to worry about that, and it's probably going to take a little bit too much time. But scalar displacement, this is where we go here to plug in our scalar displacement map. So I'm going to grab that, I'm going to go to File, and I am going to literally browse to my rock, and I'm going to plug in my displacement map like so. Cool. So that's plugged in. Let's go back to that. Displacement amount literally displays the amount. It controls, oh there we go, controls the scale or the vector of the scalar. So if you want to crank it up even more, you can. Put it in there. Displacement map center. Yep, no, the rest of it we're just literally going to leave as is. We're not going to touch it. If anything, we're going to be playing around with our displacement amount. Okay. Now, the next step, I'm going to have to try two different ways. I cannot remember if I need to apply it to the, again, my brain is just failing me at the moment, if I need to apply it to the actual shape node or the shader node. So we'll try it to this shader node first. So let me just pipe these out so we've got everything we need. And actually what I'll go do before I jump ahead of myself, I'm just going to go and plug in my diffuse color as well, so we've got some rocks to look at. You can see down the bottom here it's kicking up a few issues. It's looking for the dot text, so I probably should convert that to text, but I'm not going to worry about it just now. Diffuse will do the trick. So let's actually just have a look here. I'm going to try and apply it to, I can't remember if it's here. Well, if it is the actual shape node itself. You know what, let's actually try the shape node. No, I'm going to do it to the shader first. Worst comes to worst, I can just remove the attributes. Okay, so there's a couple of attributes that we need to add. Sorry, wrong node. Pixar Disney. Attributes, Renderman, manage attributes. Now, displacement bound, displacement base. Displacement bound just means that I can actually control a few of the options in the RMS displacement node actually in the shader itself, as opposed to having to go back to this node here. Displacement bound, displacement space. What else? I think it's trace displacements. I think that's it. I am terribly sorry if I'm actually forgetting something. It's been a while since I've actually needed to use displacement. So I'm going to add those. And I can see that those attributes have been added down the bottom of my shader node. It's saying displacement bound. Oh, yep. I have a feeling I'm forgetting something actually. Let's just go ahead and do a render anyway and see if this is actually going to work. I might just get rid of all these guys over here. No, I'll leave them. Who cares? Let's go ahead and fire off a render. Cool, it's not working just yet. Let's go and crank up the I probably should have tested this first. I'm going to crank the displacement amount up to 5. Yes, I am actually putting them in the wrong position. The node's in the wrong place, I think. You know, I might actually have to skip this. I honestly cannot remember off the top of my head right now. Let me just have a look at the attributes again in case there was actually one that I forgot. Subdivision scheme. Gosh, I can't remember. I don't need all of them. Ray trace. Yeah, I can't quite remember. I'm going to just quickly fire off another render of that. Yeah, no, maybe it is actually the actual the shape node I actually need to add it to instead. Manage attributes. Alright, cool. So pretty much just added the exact same nah, it's not going to work. Alright, I'm going to have to unfortunately scrap that. I just cannot remember off the top of my head where it is I actually need to add those attributes. Sorry. Yeah, no, I will scrap that. I just, yep. I cannot remember. That's right. I'll be doing another. I'll probably be doing a whole bunch more of this a little bit later. Anyway, I'll be doing another workshop where I do a bunch of other stuff. We'll do some render passes and we'll revisit displacements when I refresh my memory. It's been a while. But we'll do AOVs and stuff in the next workshop that I do on Renderman as well. Cool. Well, I'll tell you what. I might actually wrap this one up a little bit early, just because, yep, I cannot remember. My bad. And yeah, cool. I hope you guys enjoyed it, and we're gonna leave it at that. And I shall probably see you guys in the next installment of the Renderman workshop, which I'll be doing probably in another month's time or so. And again, in that time, we'll revisit displacements and we'll take a look at some AOVs and possibly even do like a little bit of a lighting workshop where we'll actually run through the process of setting up our scene, having a look at a few extra kind of little advanced things. We'll probably do some caustics and stuff, as well as maybe even an underwater scene. I don't know. We can have fun. We can do a whole bunch of cool stuff. But I'm going to leave it at that, and I shall see you guys all in the next in the next workshop. Cheerio.